Good evening, everyone. Welcome to the today's 11th physics class. I am excited to dive into a fundamental topic today, that is scalars and vectors. Okay, so these concepts are crucial for understanding many areas of physics. Okay, so before we begin, can everyone quickly type in the chat box if you can hear me clearly and see the screen? Just a quick yes, sir. Hear you, sir. Any response? Okay. So it looks like we are all set. Okay. Okay. So to get us started, I want to share a fascinating real world example of why understanding vectors is so important. Okay. So think about Apollo mission, okay, where humans first landed on the moon. NASA engineers had to perform incredibly precise calculation to send astronauts safely to the moon and bring them back. They used something called vector analysis. Okay, vector analysis to calculate the exact trajectories needed. Without a deep understanding of these vectors, these missions simply would not have been possible. It truly highlights how physics and specifically vectors play a critical role in groundbreaking achievements. Okay, so now before we jump into the details, can anyone share one example of scalar or vector quantity you have encountered, perhaps in our everyday life? Or can anyone share one example of a scalar or vector quantity? Please unmute yourself, or you can chat in the box. Please tell any one example for a scalar quantity, or maybe it may be a vector quantity. Any example? Already you know that what are the scalar quantity and what are the vector quantities. Yeah. So any one example?
Rama.
Hmm. Please tell. Okay. So okay. Right. So to kick things off and warm up our brains, we are going to do quick 3 or 4 quiz related to these scalar and vectors. Okay. Okay. Right. So this quiz will help us to recall some basic physics quantities and coordinate system. I am going to share that quiz. Please wait.
Hey, ఆపండి.
Hello. Okay. So this is the first question. What is a scalar quantity? What is the definition for that scalar quantity? Option A, it is a quantity with both magnitude and direction. Option B, it is a quantity with magnitude only. Option C, it is quantity with direction only. And option 4, it is a quantity that always a scale. So what do you think about this option? You can unmute yourself or you can chat in the box. Each question takes only 30 to 40 seconds only. Okay. So quick. What is a scalar quantity? Okay. Yes. It is a quantity with magnitude only. Yes. Is it correct? Option B. Yes, correct. Okay. Then next one. One of the following is a scalar quantity. Which one is it? Speed, velocity, acceleration, force. One of these is a scalar quantity. Speed or velocity. First one uh, for the first question, there is a response. Very good. Great. For this second question, option B. Yeah. Or for the first question. Okay. Okay. So one of the following is a scalar quantity. Already you know that scalar quantity, that quantity has direction, value only, magnitude only, does not has a direction. So here you can see speed, velocity, acceleration, force. Velocity, acceleration, force has both magnitude and direction. Speed only, it has direction only, it has value only, not a direction. So speed. Okay, this is the correct answer. Very good for your response. Okay. So here another one important question. Explain why 5 kg is a scalar quantity. Already you know that mass 5 kg denotes or represent the mass. Okay, that is a scalar quantity. But why? You have to explain why. I'm audible. Someone respond as not audible. Okay, explain why 5 kg is a scalar quantity. Option D, someone answered because it is a magnet with the direction. Okay. Is there any uh, response from other students? Someone answered option A or option B, option C or option D. Why 5 kg is a scalar quantity? Okay. So option D is a correct answer because it is a magnitude without direction. Okay. So it is a magnitude. 5 kg is represent the mass. So it has magnitude only, not a direction. Okay, great. Someone respond. Very good. Great, great. Okay, right. Right. So let's now formally define what scalars and vectors are. Okay. So first scalar. Scalar quantity is something that only has magnitude. Yes. Something that only has magnitude. Think of magnitude as simply something like amount or size. It does not have a direction associated with it. For example, distance. Okay. So if I tell you I walked 5 kilometers, that is just a magnitude because 5 kilometer denotes my distance. Okay. So it's just a magnitude only. Next one, speed. So my car is going 60 kilometer per hour. That means it has only value, magnitude. Time. The class is 60 minutes long. Yes. Weight. that is mass. Okay, mass. I weigh 70 kilograms. Okay, so these are all the example for scalars. Is it clear? Okay, so now let's talk about vectors. Vectors. So let's talk about vectors. Okay, so a vector quantity has both. Yes. Okay. So a vector quantity has both magnitude and direction. Okay. So the direction is just as important as a size. For example, displacement. So if I tell you I walked 5 kilometers, but 5 kilometers north, that is the displacement. It includes direction towards the north. Okay. So velocity. My car is going 60 kilometers per hour east. So it includes direction. So that is the velocity. It includes direction and value. For example, force. Another one example, force. I pushed the box with 10 newtons of force to the right. So right is a distance, direction. Yes. So another one example, acceleration. Okay. So acceleration is object is speeding up at 2 meter per second squared downwards. These are all the example for vector. So vector quantity has both magnitude and direction. Okay. Okay. Now proceed, madam, please.
Yes, sir.
Yes.
I think everyone understood. ఏంటి వెక్టర్ ఏంటి స్కేలర్ ఏంటని సార్ ఆల్రెడీ చెప్పారు కదా, మీకు అర్థమైందా మీకు? ఓకే, నేను జస్ట్ మీకు ఇక్కడ చూపిస్తున్నాను కొంచెం ఎగ్జాంపుల్. ఇక్కడ చూడండి, చూస్తున్నారు కదా మీరు, సార్ ఆల్రెడీ ఎగ్జాంపుల్స్ అన్ని చెప్పారు. ఇప్పుడు ఏమంటారు, టెంపరేచర్ ఒక ప్లేస్ లో ఎంత అని అడిగితే 35 డిగ్రీ, సమ్మర్ లో ఎంత ఉంటుంది? 35 డిగ్రీ ఉంటుంది కదా. అవి అన్ని స్కేలారా వెక్టారా? టెంపరేచర్ స్కేలారా వెక్టర్ క్వాంటిటీయా? ఇప్పుడు నేను నా ఇంటి నుంచి నా ఫ్రెండ్ ఇంటికి వెళ్తే, సపోజ్ నేను విజయవాడలో ఉన్నాను, నా ఇల్లు తర్వాత నా ఫ్రెండ్ ఇల్లు ఉంది పక్కన స్ట్రీట్ లో. ఇక్కడ నుంచి అక్కడ వెళ్తే టెంపరేచర్ మారుతుందా? మెషర్ చేస్తే మారదు కదా. సో టెంపరేచర్ ఇస్ అ స్కేలార్ క్వాంటిటీ. ఇక్కడ చూడండి, 27 డిగ్రీ అంటే 27 డిగ్రీ అంతే, డైరెక్షన్ లో మారదు అది. అర్థమైందా? సో దట్ ఈస్ అ స్కేలార్ క్వాంటిటీ. నెక్స్ట్ మాస్. మాస్ 54 kg అంటే 54 kg అంతే ఉంటుంది. ఎస్, మాస్ ఇస్ ఆల్సో అ స్కేలార్ క్వాంటిటీ. నెక్స్ట్ స్పీడ్. స్పీడ్ కి ఫార్ములా చెప్పండి ఎవరైనా. లాస్ట్ చాప్టర్ లో చదివారు కదా మీరు, ఎవరైనా అన్మ్యూట్ చేసి చెప్పండి, స్పీడ్ కి ఫార్ములా ఏంటి? స్పీడ్ కి ఏమంటారు? డిస్టెన్స్ బై టైమా, డిస్ప్లేస్మెంట్ బై టైమా? చెప్పండి త్వరగా. ఎస్, ఎవరు చెప్తారు? అన్మ్యూట్ చేసి చెప్పండి, లేకపోతే చాట్ బాక్స్ లో పెట్టండి. సూపర్, ఇట్ ఇస్ డిస్టెన్స్ బై టైం. డిస్టెన్స్ ఒక స్కేలార్ క్వాంటిటీ, టైం ఒక స్కేలార్ క్వాంటిటీ. డిస్టెన్స్ బై టైం చేస్తే స్పీడ్ ఎలా ఉంటుంది? అది కూడా స్కేలార్ క్వాంటిటీగానే ఉండాలి. సో డిస్టెన్స్ ఒక స్కేలార్ క్వాంటిటీ, టైం ఒక స్కేలార్ క్వాంటిటీ, సో స్పీడ్ కూడా స్కేలార్ క్వాంటిటీ. నేను కార్ డ్రైవ్ చేస్తున్నానంటే 38 మీటర్/సెకండ్ లో వెళ్తున్నానంటే అది స్కేలార్ క్వాంటిటీ. ఇప్పుడు అర్థమైందా? నెక్స్ట్ వెక్టర్స్. సపోజ్ నేను ఇక్కడ నుంచి ఇక్కడ నడుస్తున్నాను, నెక్స్ట్ అక్కడ నుంచి ఇక్కడికి వస్తాను. అప్పుడు టోటల్ గా నేను ఎంత డిస్టెన్స్ ట్రావెల్ చేశాను? బ్లూ ప్లస్ రెడ్, అవునా కదా? బ్లూ ప్లస్ రెడ్ అది డిస్టెన్స్. దాంట్లో డైరెక్షన్ ఏం చూడము, కానీ డిస్ప్లేస్మెంట్ చూస్తున్నప్పుడు అది ఏంటి? షార్టెస్ట్ డిస్టెన్స్, అవునా కదా? ఇక్కడ నుంచి ఇక్కడ ఉంది కదా, ఆ డిస్టెన్స్ మాత్రమే చూడాలి. సో ఇక్కడ నుంచి ఇక్కడ ఉన్న డిస్టెన్స్ మాత్రమే. సో ఇక్కడ నుంచి ఇక్కడ వెళ్ళిన డిస్టెన్స్, ఇది డిస్టెన్స్ యాడ్ చేయము. డిస్ప్లేస్మెంట్ కి షార్టెస్ట్ డిస్టెన్స్ చూడాలి. దానికి వెక్టర్ క్వాంటిటీ అంటాము, ఎందుకంటే ఏ డైరెక్షన్ నుంచి ఏ డైరెక్షన్ వెళ్ళాలని టోటల్ గా చూడాలి. ఓకే, వెరీ గుడ్. ఇప్పుడు కంటిన్యూ చేద్దామా? ఎస్ సార్, యూ కెన్ కంటిన్యూ సార్.
Okay. Thanks. Okay. So, how do we represent vectors? So already you know that now what are the what is the definition for vectors and what are the quantities which is represent vector quantity. Okay. But how do we represent vectors? We often use arrows like this. Okay. So the length of the arrow. Okay. So the length of the arrow, this is a length of the arrow. Okay. So the length of the arrow represent the magnitude. Okay. And the arrowhead, this is an arrowhead. So that the arrowhead points in that direction. So this is a direction. Okay. We can also represent vectors using unit vectors and counts. For example, suppose one vector, a vector. So for example, so this is the vector. Okay. So that vector can be broken down into its components like x components and y components.
సార్ వాయిస్ రావడం లేదు, ఒకసారి చూస్తారా?
X components and y components. Yes, it okay. So it looks like a vector subscript x and it represents a vector subscript y. This is a y component of that a vector. Ax vector is the x component vector of that a vector. Okay.
సార్
Nice.
జస్ట్ 1 సెకండ్.
Yes.
చేసే బంగారు పనం మీరు ఏదైనా అడుగుతున్నారా? ఎస్, ఏదైనా అడుగుతున్నారా మీరు? మీకు ఏదైనా డౌట్ ఉంటే యాక్చువల్లీ వినిపించట్లేదు. ఏదైనా అడుగుతున్నారంటే చాట్ బాక్స్ లో కొట్టండి, ఏం వినిపించట్లేదు. ఎస్, థ్యాంక్ యూ సార్. ఎస్ పళని సార్,
Doubts? Okay, right. Okay, right. So truly visualize vector addition and resolution, we are going to use an excellent online simulation called FET vector addition. So this will make this concept much clear. I am going to share my screen and guide you through it step by step. Okay. So before that, vectors has value and directions. Yeah, magnitude and direction. So they cannot be added by ordinary algebra. Okay. Okay. Vectors cannot be added by the method of ordinary algebra. Thus, vectors can be added geometrically or analytically using certain rules called vector algebra. Is it clear? Okay. So in order to find the sum, that is known as resultant of any two vectors which are inclined to each other, we can use two methods. One is head tail method. Another one is parallelogram method. So we can add any two vectors using certain rules. That is called as vector algebra. In order to find the sum, okay, we have two methods. One is triangle method, or another it's called as a head tail method. Second method is parallel of vectors. Okay. Okay. So I will share a screen, please.
ఉంటుందమ్మా మీకు ఏం ఎగ్జామ్ ఫిజిక్స్ ఎగ్జామ్
Okay. Right. So first, notice the grid in the middle. Okay. Right. This is our coordinate system. On the right, you see a sum button. Yes. And the components boxes. And here you can see A vector, B vector, C vectors. Okay. You can drag vectors and drop here in the middle of the grid box. Okay. So first one, adding vectors using head to tail method. Head tail method. Okay. So let's grab a vector from the side panel like this. Click and drag one into the grid. So you will see the, once again, you will see the values. So here modulus of A vector is 10. That means magnitude of that vector, magnitude of that A vector. And as well as you can see also the angle. Okay. So the angle appear in the box. You can check that box on the top as well as on the vector. Okay. So this is the angle. So the angle represents that direction. Is it clear? Okay, right. Now, dragging the arrowheads, you can see the value changes. Yes. And also you can change the directions by changing the angle. Okay, right. This is so 14.2. So here 10.6. So that is the length of the vector. That is its magnitude of that vector. Okay, is it clear? Okay. Now let's add another vector. So B vector. Drag a second vector. For the head to tail method, we place the, so already I told you, this is arrowhead, this is a head of that vector, this is tail, okay, and this is a head, this is a tail. Okay, for the head to tail method, we place the tail of the second vector at the head of the first vector. Like this. Okay, so we have to place the tail of the second vector at the head of the first vector. Once you have two vectors placed like this, head to tail, check sum. Okay, you will see new vector in with appears in a blue color. So this blue color vector is a resultant vector. Okay, resultant vector. Now you can choose these values like this. Okay, so A vector, the magnitude of the A vector 10, and magnitude of that vector B 11.2. So this is a S, means resultant vector of these two vectors, which is 18. Okay, so this is a method, head to tail method. Okay, so now we can move into the another method. Okay. Okay. So we are going to looking at how to use that fit simulation vector addition to add vectors together using parallelogram method. So to do this, we can choose lab. Okay. And what I want to do is like I want to add two vectors. So I can place. Okay. So this is our coordinate system. I'm going to move our coordinates so that it's more to more clear way in the center. Okay. So first step, choose one vector. Okay. So for convenience, we can place this vector in that origin like this. Okay. And another one. Okay. So, okay. So I want to add these two vector, this one vector and this another vector. So, okay, right. So then first step is to put the tail of these two vector together like this. Okay. And I will do that at point 0, 0 just for convenience. Okay. So using the parallelogram method, what we need to do is we need to draw a vector that is equal in magnitude and parallel to this vector. Okay. So that, so here you can see the orange color vector. So the orange one represents a parallel as well as equal in magnitude to this vector, a vector. Okay. Like, so you can check that. Okay. So I have got the equal a vector that is equal magnitude. Okay. So I am going to put the tail of this new vector at the head of the other vector. Okay. Like this. So that we are adding these two vectors. Okay. Right. So this one blue color and this one orange color vectors are parallel to one another. And I am going to do the exact same thing using another one line. So which is parallel to this vector. And we will put that vector into here like this. Okay. Right. So for example, second. So I can put one value like for example, you can put any value. Okay. Right. Okay. Okay. We can place here. By using that values, you can check that parallel values. Okay. So same value between these two vectors. So for this blue vector, you can see 9.4, 32 degree, 32 angle. Okay. Right. For this. we have to do the same thing. That is value and angle, which is same as this angle. Okay, 9.4, 32. Now we can put that vector here like this. Okay, right. So we have got another vector that is equal magnitude, and I am going to make it parallel to this vector. Okay, and I have placed that parallel vector in that head of this vector. Okay, like this. So if we want to add these two blue vectors by this parallelogram, we have placed another two vectors which is in equal in magnitude and as well as direction 32 degree. So next one, I choose sum here. Okay, you can see that new vector. I draw it up here like this. Okay, right. We see exactly that this vector, blue color vector. Okay, when we added this vector like this vector, will result in this resultant vector. So that's the parallelogram method of adding vectors. Okay, so now we can see the values. First vector 7.1, second vector's value 9.4. So here you can see that resultant vector value. Okay, this is the resultant of these two vectors addition. Okay, by using parallelogram method. So this is another way to visualize vector addition, especially when vectors start from the same point. Is it clear? Okay, right, ma'am.
Yes, sir. You can continue, sir.
Okay, right, thanks. Okay, right. Now let's start with the another one case, that is vector components. So we can choose only one single vector. Okay, so now I click this. You can see that two vectors split into two components. So this is a x component, horizontal component, and this is a y component, that is vertical component. So these components are at right angles to each other always. Okay, right? Now you can see the values. Okay, so you can see that vector value 10, x component value, that is we can like say that, which is vx, this is vy, this is v. Okay, so v is the vector, it has magnitude 10, and that vector split into two components, x component and y component, vertical component and horizontal component. So vx gives vx represent the 8 units and vy 6 units. Okay, so these are the components of the that vector. So let's try to understand how these are calculated. Like I can say 8 units or 6 units, but we have to understand how these values are calculated. Okay, so think about basic trigonometry. Like if your vector v has value 10, okay, and angle. Once again. Okay, so V vector has magnitude 10 units, angle 30 degree. Okay. So Vx, that is x component 8.7, and yth component Vy, which is 5 units. Okay. So let's try understand how this calculated. To calculate the x component, we have a formula, or we have a equation V cos theta. Okay. So here V means vector, that is it has a value magnitude 10. Already you see that 10. Cos, what is the angle? 30 degree. Yes, from that graph you can change the value. You can choose 12, 13, 14, like that, and you can change the angle 30 degree, 40 degree, 45 degree. Okay, whatever else. Okay, already you know that the value of cos 30 root 3 by 2. Yes, and value of root 3 1.732 divided by these two. So you will get approximately 8.66 units. So we can take as 8.7. This is the x component of that vector, which has magnitude 10. So now you can see that same graph. Just look at that x component value 8.7. Okay. And for the y component, 5 units. For y component, we have a equation like that. Vy is equal to V sin theta. Okay. So we can put the same value. Okay. 10 sin 30 degree. Already you know that the value of sin 30 1 by 2. So 10 into 1 by 2 we can cancel out, and we will get 5 units. That's why you saw that in that y component there is a 5 units. Okay, this is uh, like a step for that component, how to find the two components of that vectors. Okay, right. So now we can move into that like numerical problem, and then we will go into that 5 MCQs. Okay, right. I will give only one problem, numerical problem. Okay, two vectors. One is A is equal to 3i plus 4j, and B vector 2i minus 1j. Okay, so find the resultant vector. Already you know that I is the unit vector for the x direction, x axis. J is the unit vector for the y axis. Okay, so find the resultant vector. This is the question. Okay, so to find the resultant vector, we simply add their corresponding components. Already you know that about components. There is a two components, x component, y component. For the x component, I. For the y component, j. Okay. So resultant denoted as capital R. So R is equal to A plus B. Like that. Okay. So we can put For A, 3i plus 4j. For the B, 2y minus 1j. Clear? Okay. Just add their corresponding components. For example, you cannot add 3i to minus 1j. Okay. Just add their corresponding components like that, plus 4 minus 1 into j, like this. Clear? Okay. So 3 plus 2, 5. 5i. And 4 minus 1, 3j. But this is not a resultant vector. Okay. So to find the value, magnitude of this resultant vector, we use the Pythagoras theorem. Yes. Okay. So for that, take modulus. So modulus means magnitude only. Yes. So x component square and y component square. So you can see that there are two components here. One is I and j. So x component, y component. So that vector, resultant vector, split into two components. Already you saw that. Yes. So to find the magnitude of this resultant vector, we use the Pythagorean theorem like this. So rx square plus ry square roots. Now put that rx and put that ry. Just take that value only. So for the ith component, 5. So this is a x component of that resultant vector. 5 square. For the ry, you can take that 3 only. So 3 square only. Okay. So if you have any doubt, you can unmute and or in the chat box you can say if you have any doubts. Okay, right. So 5 square 25, 3 square 9, which gives 34. If we take the root of 34, we will get approximately 5.83 units. You can check it in our home. Okay, right. So this is a value of that or magnitude of that resultant vector, that two vectors. Okay. Okay. So like this type of problems are the fundamental to understand how vectors are used in physics. Okay. So speaking of uses, vectors are crucial in many real life applications. For example, in navigation. Think about how GPS works. It uses vector principles, okay, to determine your exact location. Already you know that GPS, okay, which gives your exact location. So it uses vector principles and guide you to your destination. Okay. Then projectile motion. Some of the important uses of vectors. Okay. Projectile motion. So when you throw a ball, it goes like this, like this. Yes, you throw the ball, it goes like this. Its path can be analyzed using vectors for its initial velocity and force of gravity acting on it. And in the field of engineering, engineers use vectors to analyze forces on structure like bridges and buildings, ensuring they are stable and safe. Okay, these are some of the important, crucial exam application in our day-to-day life. Okay, right. So time for another quick check on our understanding. I have prepared 5 multiple choice quiz covering today's concept, scalars, vectors, and operation. Okay, I will share your screen. Okay. So, first question. What method is used to add vectors graphically? Pythagorean theorem, head to tail method, scalar multiplication, or dot product? What method is used to add vectors graphically? You can unmute yourself or you can chat in the box. Or simply you can note it in that in our book. Okay. So option B, head to made, or Pythagorean theorem, option A, like that. What method is used to add vectors graphically? We cannot add vectors with ordinary algebra. Already I told you. So vectors can be added geometrically or analytically using certain rules. That is called as vector algebra. But in that vector algebra, we have 2 methods. Is it correct? Okay. Okay. So any response from your side? What is the option here for the first question? It may be A, or it may be B, C, or D. What is that answer? Okay, someone responds. The question. Yes, please unmute yourself and please say the answer. Okay, right. Uh, okay, there are good responses. 2C, B. Oh. So for the first question, B. Very good. Very good. Good. Super. Very good. So B. Head to tail mail method. Okay, right. So for the second question, this is the second question. Which application commonly uses vectors? Measuring temperature, calculating distance, navigation in GPS systems, measuring volume. So which application commonly uses vectors? For the second question, someone A and someone tells C, B and C. Good, good. C. Very good, very good, good. So for the second question, answer should be C. Okay. Okay. Navigation in GPS system. Okay. Very good. And we can move into the third question. Okay. What is the result of the dot product of two perpendicular vectors? Already you know that that answer. Yes, dot product of two perpendicular terms. It may be like I dot j, j dot k, like that. Yes. So I dot j or j dot k or I dot k, which gives 3a. Yes, product of their magnitudes. Yeah. No, that product means multiplication. So I cross j is the product of their magnitude. But here, result of dot product. So we have a two type of product. One is scalar product, that is known as dot product. Another one is vector product, that is also known as cross product. Okay. So dot product of two perpendicular vectors, which gives 0. Okay. So note it down. Result of dot product of two perpendicular vectors, resultant 0. Okay. Very good. Okay. Someone answer B. Very good. Very good. Super, super. Good. Right. Yes. Answer B. Answer B. Very good. Very good. Super. Now we can move into the another one problems. Yeah, vector has magnitude components already. You know that Vx and Vy. So that vector has components x component, Vx is equal to 3 units and Vy is equal to 4 units. What is its magnitude? Already we saw one problem related to this magnitude Vx, Vy. Vector has components 3 units, 4 units. What is the answer? Someone please. Three units and 4 units. What is the value? Okay, good. 4 A, 5 units A. Quick. Very good. 5 units. Very good. Very good. KGBV, Anandapuram. Very good. 5 units. Krishnavini, GJC, girls, C2, 4A. Very good. A. Yeah, yes, yes. Very good. So 5 units is the correct answer. Very good. Very good. Super. Great. And then we can move into the last one. A boat travels with a velocity vector 5I plus 12J meter per second. Already you know that is a unit for velocity. What is the angle of the velocity vector with respect to positive x-axis? A boat travels with some velocity. So with the direction, we have to put like that. So 5I plus 12J, because that vector is split into two components, I vector and J vector. That is x component, y component with the units meter per second. What is the angle theta of the velocity vector with respect to positive x-axis? Already you know that the angle in that in our diagram, there is an angle. That angle is between the that vector to the positive x-axis. Yeah. So what is the answer? B. Someone answered B. Okay. A. B. Hey B. Yeah, I expect more response from many other schools. Yes, yes. Okay. Okay, 30 degree, 45 degree, 67.4 degree or 90 degree. Okay, very good. Government Junior College Boys Pakala. Yes, very good. 67.4. Good, good. So answer, very good. 67.4 degree. Okay. So you can see that. Now check that answer. Okay. Right. Sorry. Now we can see the score. What method is used to add vectors graphically? Head-to-head method. Very good. Which application commonly uses vector? Navigation, GPS systems. What is the result of the dot product of two perpendicular vectors? 0. Very good. Vector has magnitude already. Many of the schools replied. Okay, 5 units. Very good. And the final one, a boat travels with velocity. The angle of velocity vector 67.4 degree. This is a correct answer. Okay, very good. Very happy to see this. Okay, right. So I had like to hear from a couple of you. Can you tell 2 or 3 students volunteer to explain vector addition or resolution in your own words? You can either unmute yourself or type in a chat box. You can tell that what is vector or what is scalar, or you can say the simple words about vector addition. It may be head-to-tail method or it may be a parallelogram vector. So just to reiterate, the application of vectors are vast and incredibly important in the modern world beyond what we discussed in GPS navigation, robotics. Robots move their arms and manipulate objects involves complex vector calculation. Okay. In physics simulation, from simulation fluid dynamics to predicting planetary motion, vectors are the core. Okay. So as we wrap up today's class, let's quickly summarize what we learned. We started by understanding the fundamental difference between the scalar magnitude only and vectors, magnitude and direction. Okay. So vector operations like addition and finding components, and we looked at some crucial real application of vectors from like Apollo mission to GPS navigation system. Okay. So for your homework, just write this to sum. Okay. This is your homework. A vector has a magnitude of 8 units at 45 degree to the x-axis. Calculate x and y components. This is the first question. And second question, find the resultant of vectors. A, that is 4i plus 2j, and B, minus 1i plus 3j. Okay. For your homework, please complete the following problems. Okay. So thank you all for your active participation today. I hope you now will have a clearer understanding of scalars and vectors. See you in our next physics class. Okay. Thank you. Jai Bharat, Jai Hind.
Yes, Karthik sir, we can end the session, sir.